So I want to thank everybody for attending today, and I'm going to welcome you to our fifth presentation in the Getting to Zero series. Today's program is on heat pump myths, design issues, and operating recommendations. It's going to be presented by Rob Basnett. And Michael, I'm correct that this is going to be kind of a question and answer,
right? Yeah.
Format.
Yeah.
The session today, the series actually is hosted by C-Free, and that stands for Carbon-Free Residential Everything Electric. We are a working group of the Lincoln Green Energy Committee. I've had a lot of questions lately about C-Free, and I want to make sure that people understand it's C-Free, not C3 as in the number 3, because there's a lot of confusion out there. We are C-Free, carbon-free residential, and our focus is working with residents and others to reduce their greenhouse gas emissions through energy conservation and the use of appliances and vehicles powered by renewable electricity. On your calendars, please add May 27th, which is, let's see, wait a minute. Am I right on that, Belinda? May 13th.
May 18th and May 27th.
May 18th and 27th. On the 18th, we have Mike Dowdy coming to talk to us. He's a builder in the community and does a lot of retrofits. It's going to be a very interesting presentation. And on the 27th, we have Paul Gromer coming in to meet with us, and he heads Peregrine. They put together our aggregate program. So those are two interesting dates coming up. And with that, I'm going to turn this over to you, Michael, to start the program.
Okay, thanks, Colette. So this is our third presentation on heat pumps. We did two in early 2022 and focused on demonstrating that heat pumps are cost effective and reliable in Massachusetts. And our sense now is that work is pretty much done. Last year, heat pumps outsold gas furnaces nationwide for the first time. And it's, definitely there's all the momentums on the heat pump side. So our focus now is on helping people find the best heat pump solution for them and using that heat pump or those heat pumps efficiently. So we'll start, let's go to the next slide, the agenda, Belinda. So we'll start with just a very brief overview of heat pumps, and then we'll do an interview of just a sort of discussion with Rob, and finally we'll open the floor to questions. So Rob Basnett founded Basnett Plumbing, Heating and Air Conditioning up in Littleton, Mass. in 1987. We learned about him from the list of satisfied customers that Alice Waugh maintains for Lincoln. He's built a strong business by focusing on in-depth training of personnel. We talked a lot about that when we first spoke with him, and high levels of customer satisfaction. So he calls his people that you meet with comfort consultants rather than technicians. So that's a really nice focus on what their concern is. And he puts a lot of emphasis on measuring and monitoring, testing every system that he installs. He's a lifelong hockey player and avid outdoorsman, and he's actually coming to us from Rangeley, Maine now. So up where the really lovely outdoors. So welcome, Rob, and we'll get back to you in just a second. Next slide, please, Belinda. So let's jump to the quick overview of heat pumps. So 3 criteria define a heat pump. Where's the heat come from, and where do you dump it when you're in the summertime and you want to get rid of heat? Is the heat pump ducted or ductless? And is it single zone or multi-zone? Next slide. So first, where's the heat come from? So you'll see on the left here, a common outdoor condenser for an air source heat pump. Air source heat pump, as its name says, gets its heat from the air, and it dumps any excess heat into the air. So you see their fans behind the grills there. They blow air over coils, and all the exchange happens between that system and the outdoor air. And yes, it is possible when it's 14 degrees below zero to still suck heat out of that outdoor air and warm your house with it. We saw that this winter. And on the right, you see a ground source heat pump. There, you don't have any outdoor unit like this because all the heat is coming out of the ground. You've got pipes buried deep in the ground where it's 50 degrees year round. And so you've got lots of heat there you can draw from and a good place to dump excess heat in the summertime. Ground source heat pumps, also known as geothermal, they're more efficient and last longer than air source heat pumps. But usually are significantly more expensive, even with really great incentives. So that's a shame. People are trying to bring the costs down, but it's still a big jump. Next slide, please. So now we talk about the next criterion, which is ducted versus ductless. So on the left, you see a standard central heat pump with a condenser outside, and inside you can see an air handler like you would have in the basement currently for your furnace, with ducts running from there throughout the house. So that's the ducted system. And the ductless system on the right, you see outdoors here, you'll see the condenser, and indoors you'll see a what they call a head or an indoor air handler, all kinds of different names for it, that actually distributes the heat into the room. So for ducted systems in a retrofit, it may be possible to use the existing ducts, but not if they're old, leaky, or uninsulated, or if they run outside the conditioned space. So if you have an unconditioned attic, you don't want to be using your old ducts if they're running in that unconditioned space. It's disastrous. And also that ducts that are sized just for air conditioning may not work for heating. So if you're thinking about putting in a ducted system, you really need to work with your installer and look closely at whether your existing duct system is going to work. Next slide, please. So here for the ductless units, you can see three different types. You'll see a head up high on the wall in the left-hand picture, in the ceiling, in the center picture, and down on the floor on the right. So you've got different options for where ductless heads can go. Next slide. And the third and final criterion for what defines a heat pump is its single zone or multi-zone. So you can have one mini split condenser outside with up to 5 or more, I believe, even zones inside. So different heads scattered around in different rooms. The single zone has one condenser outside, one head inside. Multi-zone is one to many. Next slide. And okay, so let's go to the next question for you. What configuration of heat pumps is right for your home? So given that what we just talked about, how do you decide? So two common scenarios. Next slide, please. So if you have an existing duct system and it's suitable or can be made suitable with some work, then the central ducted system's pretty much a no-brainer. Really straightforward. If the existing ductwork is good, you basically get rid of your furnace and you replace it with an air handler that connects with your condenser outside. So you're basically just getting rid of your furnace and replacing it with the heat pump condenser to supply the heat. On the right, in a ducted system, if you currently have baseboards or radiators, whether it's from hot water or steam or electric resistance, the easiest solution is normally to use all ductless units, perhaps with one or more multi-zone systems. That's a whole trade-off. We'll talk about that later. Or you can have a combination of ductless units and what's called a compact ducted system. So in our house, for example, on the main floor, we have a mini split, one of these single zone units for the living room, another one for the kitchen and dining room. And then we have a compact ducted system that serves the master bedroom, the master bath, and the study. So next slide, you'll see a picture of a compact ductless, sometimes called pancake unit. It's very, now it's only, I don't know, 4 or 5 inches deep, so it fits in kind of tight spaces up in a ceiling of an attic or a hallway where you could box it in. And on the end that's shown here is where the air goes into it, and on the far end or different sides, you have ducts coming out, usually very short. So the one that we have is just in a hallway between the master bedroom and the master bath. So you've got like a 1-foot duct going to the master bedroom and a 1-foot duct going to the master bath. So these are really great little systems. Okay. Let's see. Okay, next slide. All right, so that's a very fast summary of heat pumps, and hopefully it'll give you a little sense of some of the issues we'll be discussing later with Rob. So let's bring Rob in and ask him some questions. So we'll start with some myths first. First myth: heat pumps only blow lukewarm air. So what's your experience with that, Rob?
Well, it's definitely less than gas and oil. Typically, an oil furnace is anywhere from 130 degrees to 160 degrees. Gas is a little bit lower, and it's 120 to 130 degrees. And the heat pump will put out anywhere from 90 to 110. So people might think it's lukewarm because they're used to something a little bit warmer. However, that 90 to 110 degrees is enough to heat your home, providing the calculations are correct.
Yeah, I got 2 examples of one very, very sophisticated technical measuring device, a man's cat who always slept under where his mini split blew the hot air. So, and you can't argue with a cat for locating the warmest place to spend their time. And we also had on the coldest day when we were down at -11 here in Lincoln, the coldest day we had this winter, we had a friend over, and in the day following, and she was expecting, she knows our house is heated with heat pumps, and she was expecting to be, a little chilly. So she came, with multiple layers on. And I found her standing under the mini split, which was, blowing really nice hot air down. She was sort of taking a hot air shower. And I said, "Oh, pretty nice." She said, "Yeah, I'm surprised. This is great." So those are 2 testimonials from different mammals. Okay, second myth: heat pumps don't work when it's really cold. So what's your experience in that regard, Rob?
That's an old myth because for years it was like, oh, the heat pumps don't work in New England. Well, they've changed the refrigerant. We use different refrigerant than we did in 2010. So since 2010, there's been a mandate that they got rid of the old refrigerant. They have this new refrigerant, and the new refrigerant actually has a boiling point that's a lower temperature, which sorry about that. Which will produce more heat. Aside that, the technology has come a long way. I mean, it's just crazy how well the outdoor units are constructed. I mean, there's inverter-driven outdoor compressors that actually fluctuate and modulate, based on what the need is inside the house. So the units have come a long way. However, I'll still mention that there are units that you can get that will not go down to a very low temperature. So it depends on what you're looking to accomplish. If you're looking to accomplish heating your home at a low temperature, then make sure that you ask your contractor and let them know what you're trying to accomplish with your home. Because a low grade heat pump might go down to 30 degrees outdoor temperature. However, but the new ones, they'll go down as low as minus 13 degrees. They'll give you less output, But yeah, so that it's definitely a myth that they won't go down to a low temperature.
Okay, so this is a slide of showing the capability or heating capacity of some Mitsubishi mini splits. And so basically you've got on the bottom axis, you've got the outdoor temperature, minus 13 on the left and 47 on the right. And so then the red line shows that, that from 47 degrees Fahrenheit, the Mitsubishis are at 100%, and that 100% capacity continues all the way down to about 5 degrees. And then below 5 degrees, they start to drop off. And depending upon which model you have, some are more sophisticated and efficient than others. At minus 13, you may be at 93% or at 76%, depending upon the model. Whereas with a standard heat pump, and standard is a really, really not a very helpful term here, but as Rob said, there are heat pumps out there which which do not perform very well, and especially as the temperatures drop. So you see at 47, they're at 100%, but at 30, they're down at 80%, and at 10, they're at 60% of their capacity. You do not want a heat pump like that in a cold climate like Lincoln. So there are restrictions on what heat pumps Mass Save will give you a rebate on. And so when you're working with a contractor, you need to be 100% sure that they're giving you a cold climate heat pump. And but ask the hard questions. And how does it perform when the temperatures start dropping? My son-in-law in Indiana is about a little warmer than here, the part where they are, but still in the same climate zone. Unfortunately, his installer sold him a heat pump that wasn't really a cold climate heat pump, so he gets into into a pickle when the temperature drops, and it's just then he's relying on the resistance heating, which is disastrous. And another friend in Newton had similar problems. So somehow or other he ended up with a heat pump that really wasn't the quality it should be for Lincoln. So this is a question. Really dig deep with your with your installer. So the question I asked Rob if he'd had any feedback from his customers during the cold spell. So I did an experiment here. We're in a deck house, but pretty significantly renovated for energy efficiency as much as you can with the deck house with all the glass. But we ordinarily just keep the mini splits on the main level operating, and we don't have the ones on the lower level working in the winter because it's really well insulated. It's also partly, like deck houses are, built into the hillside, and so it fluctuates between sort of 55 and 60 down there without any heat through the winter. So we went into this minus 11 or minus 12 night, and I wondered how we were going to do. And so with just the upstairs 3 mini splits operating, we lost 3 degrees overnight from 70 to 67 by the morning. So I was pleased. They obviously worked hard, but they kept up, quite well with no help from anything on the lower level.
Last question you were asking was
yes, I was asking if any of your customers had or if you've been talking with anybody who has a heat pump and how they did in that really cold spell when it was 12 below zero.
Yeah. So most of our calls was actually freeze up calls, frozen pipes, and there was some power outages. So there was surges that actually caused issues with some of the controls on some equipment, not necessarily heat pumps either. On the heat pumps, I don't care whether it's heat pump, fossil fuel or not. we size for when it's around, depending on the area, somewhere around 2 degrees outdoor temperature. So it got, minus 11 degrees. We're not designed around here for that. So I don't care what you had for heat. Most people were a little bit colder than it wouldn't keep up. So we were having some calls saying, hey, my system won't keep up. And we explained to them why and what to do and to wait. And then, by the next day it was fine.
Right.
So, and we're actually regulated by the towns and by the state that we can't size it for that temperature. And you wouldn't want us to size it for that temperature. And we'll probably go into that later on in the design when we get to that point.
Right.
But essentially, it didn't matter whether you're on heat pump or not. It just wouldn't keep up,
People were so okay. So what are homeowners' options if the temperature falls below the lowest limit? So what do people fall back to?
Well, there's a few things. It depends on what you're looking to accomplish. If you're looking to go all electric, then there's a backup strip heat that you can put in the unit itself, so it can actually switch over from heat pump to use your strip heat, and then it's using all electric, just the strip heat, and the air still blows like it normally would, and it's using a different electricity or a different electric unit.
That would be for a central system, not for a mini split, right?
Correct.
Right, okay, gotcha.
Mini splits, there's not much you're going to do on the actual mini split itself, but you could put electric, strip heat on the wall. If you had your fossil fuel that you didn't get rid of, you could use that as a backup. If you have an existing system, those are the type of things. It depends on the home and what they're trying to accomplish.
Right. Gotcha. Okay. So to that exact question, can a person keep their existing heating system as a backup if they install heat pumps and still get the mass save rebate? This is a trick question.
Yeah, I mean, it is a trick question because it's a gray area, They do allow that. They want you to just use it as backup only, or an emergency case where your electric source actually went down and it's not in operable position. Then you can use your backup heat. So you could, still get the 100% rebate as long as you don't use it as your primary source.
So yeah, and the Mass Save website has some really good language on that. So it's as he says, a little gray. So if you're thinking about doing that, read that and be real clear on what you can and can't do with a fossil fuel system that you've maintained. Okay, all right. Next slide. Go to some design questions. So, Rob, does your firm do manual J calculations when you're sizing a heat pump system?
Yeah, it doesn't matter whether it's heat pump or not. If we size it, anytime we're doing heating or cooling, we're going to do a manual J.
Can you explain what that is and why it's important?
All right, so a manual J is basically, that's a calculation where we take measurements of your home and figure out what you need for heating and cooling, depending on what you're looking to accomplish. We're measuring all the square feet of your home, outside windows, your outside walls, what your insulation R value is, your floor R value, anything that has to do with the heat load itself. And then we're putting it in the software and calculating what do you actually need. That's actually believe it or not, the best company out there for software is right in Lexington. It's called RightSoft.
Ah, cool.
Yeah.
Cool. So what would a firm that doesn't want to take the time to do the manual? Because I understand it's a bit time consuming. You take measurements and inputting stuff. What would they do in place of this?
I can't speak for them.
I was hoping
I'd
get a good laugh on that. Go ahead. I'm sorry.
I can tell you what actually happens. Is a lot of people just take what's existing, right? There's a big assumption of, what you have in your home is what you need. And that's a huge assumption because they're assuming that the person that, or the company that sized it the first time did the right size. And that's a huge assumption. So if you don't see anybody taking measurements and talking about a load calculation, then I would be asking them questions, because all they're gonna do is give you a price on what's existing. And that might not do it, or it may be oversized, which is even worse.
Okay, cool. So what are the key factors in deciding if the existing ductwork would work well for a new heat pump system? And we talked about this very briefly, but what things do you look at?
Well, first of all, location of the ductwork, like you had mentioned earlier, if it's in your attic, it's just not a great place. Ductwork in the attic is not a great place because essentially you want your attic as cold as possible so you don't get ice back up on your roof. So think about that. Now you're putting your ductwork in your attic. That means that your ductwork is outside. And if your ductwork is leaking, which most of it does, because if it was installed prior to 2010, there was nobody sealed the ductwork. Then it's actually sucking in the outside air and the attic air, and it's blowing it through your house. So location is key. Now, that doesn't say that you can't do it. What I would recommend in a lot of cases is that when I get asked, like, hey, I got a cold room, can you put more heat in it? Sometimes that's not the answer. The answer would be, let's tighten up your home, call an insulation company and have your home tighter and keep the heat inside the house and not outside the house. So I don't agree with putting more heat into somebody's house because they're a little cold in one room. Let's address the issues of your home. So in the attic, if your ductwork is in the attic, one way to fix that is to make your ductwork in the conditioned space, which would be to reconfigure how the insulation is done, which would mean insulating the rafters instead of the floor of the attic. That's one way that you can correct that issue. But to your point in your question earlier is that ductwork is key. We're looking at the sizing. We're looking at if it's sealed or not. Is it insulated? How many supplies and returns does it equate to what you actually need? We're not going to be able to tell that right away. That's where we get some gathering. You gather the information, and then when you do your load calcs, you can kind of compare what your load calcs are and what you actually have in your home, and then we can determine at that point, all right, the ductwork is good or it's not good, or maybe we need to add, a supply or a return. Maybe we need to make the ductwork a little bit bigger on where it connects to the air handler. There's a few things like that come to play, but that's a big consideration is the ductwork.
Good. You talked just a minute ago about oversizing. Can you talk about oversizing and undersizing and sort of what the pros and well, not pros, I think they both have problems, but the issues involved?
So this is really something to consider or think about on heat pump, because typically here in New England, our heating load is going to be more than our cooling load. And if you're looking to heat your home 100% with a heat pump, that means that you might be sizing the heat pump for heat, but then it's oversized for cooling. And then during the cooling season, that's a bad thing because it's not going to remove enough moisture. It's going to short cycle. It's going to cause inefficiencies. I mean, the list goes on. It's just not a good thing to oversize.
So how do you balance that then?
That's a good question, because that comes down to design again, and getting doing the data collection when you go there, when the comfort consultants go there to get the information. It starts with what are you trying to accomplish? If you're trying to accomplish, heating your home down to 0 degrees with a heat pump, that's a conversation to have. But then when they come back with that and you ask that question, hey, will it do that? Am I okay with that? There should be follow-ups of how's the AC going to work? and or the designer should be looking at that saying, having a conversation saying, this heat pump, we could size it to go down there, but you're gonna have issues in these other areas. And here's the way to go about it. You can size the heat so you can get almost 100% or maybe 100% down to say 20 degrees or 15 degrees. And then you're using supplemental on top of that afterwards, when it gets down colder. That's another way to address that. But it is something that you really want to be concerned about, is that if you're looking for AC as well, or you're going to use it during the summer, and you really want to get good AC, be concerned that if that heat pump will go down to and do 100%, you might have issues during the summer with it and not get the comfort that you're looking for.
Gotcha. Okay. Good.
One more thing, Michael, I wanted to add to
sure.
that. What makes it worse is if you had zones. Because now let's just say you're looking for, for instance, say 40,000 BTUs, and you have two zones, and you shut one of them off. Depending on what is selected for the option to install in your home, it might be too much. And now you're actually oversizing even more because you shut off one of the zones and you only got enough airflow in half your ductwork, but you might be, but depending on the unit that's selected, it might be giving you 100% of the output.
Yeah.
So
Yeah.
So selection is a big key.
So that actually goes into exactly the next question. Well, first, a fairly simple area to focus on is, and we talked about this earlier, that you think about using ductless mini splits in an open plan area. So your living room, dining room, kitchen, whatever, your great room. Use the mini splits there, and then for bedrooms where you tend to have the doors closed, you don't necessarily want to have a head in each room. That gets expensive, and so that's where you get to these compact ducted systems, which can handle 3 or 4 or 5 rooms from a central point. So a combination of those can be done, or you can do the multiple zones from a single condenser. We talked about the multi-zones earlier, but I've heard a lot of concerns about multi-zone systems, and I just wanted to get your sense of pros and cons of those. Where do you think they're good, and where do you think there might be problems with them?
Everything's got its place. I mean, multi-zones, if you're looking to do, 4, 5, 6 indoor units, it doesn't really make sense to put 4, 5, 6 outdoor units. That means that's that many more pieces of equipment that you're going to be maintaining on a yearly basis as well, which costs money on top of it. Location, your electric panel as well, because now you're talking, let's just say you put a bunch of singles, that means you need a circuit for every single one. And that could mean that now your electric service needs to be upgraded because it can't handle it, or you don't have enough empty spaces for another circuit. So, your electric panel has something to do with it. Your service going to your house, as well as how many spaces are available for a circuit. The aesthetics, some people don't want to see that, that many units outside. Getting from one place to another is another consideration. So the multis do have, they have their place. They're a little bit less efficient, but not a ton. They're pretty good. And it depends on what the output is and what the temperature is outside. Because as the temperature goes down outside, so does the efficiency.
Gotcha.
Okay,
cool.
Michael, it's 12:40.
Yep, thanks for the update. Any comments on air to water heat pumps, Rob? Have you been looking at those or seen them used much?
No, I did. We haven't seen a whole lot used. I think they're still in the infancy stage. There's still manufacturers working on those. I think it's going to be a great thing. I can't wait till they get it down to a science and also have the output that you need. When I was looking at it, I couldn't get enough output for what we needed in these
Right.
situations.
Right, yeah, generally the temperature of water that you can generate with them just isn't good enough to work with like existing radiators or baseboards. You need to
Yeah,
greatly increase the square footage of the radiators or baseboards
right.
in order to work with lower temperature, but yeah, so
They
that-
actually, to your point though, they actually work really good at low temperatures, I mean, depending on what heat is connected to it. It's just you get less output. So the lower the
Right,
temperature,
yeah.
the less output. And if your home needs more, then it's not going to work,
So, yeah, and I think they would work well in radiant floor heating too, because there you don't need a high
Yeah.
temperature.
Radiators as well.
Okay, let's go to operating recommendations now, and we'll go through these pretty quick. See that one, that's pretty fair. How much nighttime setback should we use, if any, for the heat pump?
I'm of the mindset of set it and forget it. And always have been, because if you lower your temperature, it takes a lot more energy to get your home back to that temperature that you want it at. So, because everything, your furniture, your walls, everything is cold. So that means you got to heat that up in order to get the heat that you're looking for, especially today in heat pumps, because we're talking a little bit lower temperature output on, the airflow, the air temperature, I mean. So honestly, I would set it and forget it. Be comfortable, I mean, obviously at night, if you want to sleep, in less, temperature, a lower temperature, then knock it down. But I wouldn't knock it down to try and save money.
Yeah, generally that, pretty much everybody says, go back, if you want to knock it down a few degrees, fine, but no more than that. You end up
Right.
wasting more energy than you save.
Yeah.
So.
If you want to knock it down 3 degrees is the max, I would say.
Gotcha.
One more thing though, back to your question earlier about when it was, minus 11 degrees. That's the worst time. So if you set your thermostat back, the night before on nights like those, you're never gonna heat your house. Ever.
Yeah.
So that's another thing to consider, is that if you are of the mindset that you want to, turn your thermostat down, when it's going to be a cold day, the next day, don't turn your thermostat down the night before.
Yeah, gotcha. So a few questions about if you have an oil boiler and you want to maintain that as a backup, but you're generally going to use your heat pump pretty much all the time. There seem to be problems with leaking if you just let your boiler sit and you turn it off. What's your experience with that, Rob?
There's pros and cons. It's like an old car or a car, any car. If it sits, next thing you know, you're replacing the exhaust system, right? And you haven't even used it. I haven't seen a ton like that. I mean, because if you think about it, if you're not heating your hot water from your oil boiler, it's sitting the whole summer, right? Without being used. It is much better if it is used, but I would say maybe every once in a while, if it was used, then it'd be okay. You want to at least make sure it's going to be working too. If it's leaking, or if it does leak, there's probably an underlying problem that's going on that, there's issues with it anyway.
Gotcha. Okay, one last question. Do people with heat pumps need to worry about maintenance?
Yes. Yeah, it's the same as any other
involved?
piece of equipment. Yeah, it still has, I mean, it's no different than if they had a furnace or an air conditioning unit. It's the same thing. You got an indoor unit, an outdoor unit, a fan that's moving, it's blowing the air. You got moving parts. It's the same thing. So yearly maintenance.
Oh, okay, sounds good. Okay, so let's go into opening the floor for questions. If you want to raise your Zoom hand, at the bottom, there's a button that says reaction. It's got a smiley face. You click on that, and then you can click on raise hand, and I'll call on you in turn. Roy Harvey, unmute and you're on.
Great. Thanks so much, Michael. And Rob, it's a very helpful presentation, learning a lot here. Did want to follow up on the question of the short cycling when a system is oversized. My understanding is that modern systems with inverter-based operation, they can vary the output continuously. So do they still suffer from short cycling since they're not really, turning on and off? They're just modulating between different levels.
Good question. They can, because they still have a minimum and a maximum, right? So you still have a minimum that it can't go beyond that point, right? So let's just say 48,000 BTU unit, it might have a minimum of 20. So if you're looking for less than 20,000 BTUs, it can't do that, right? Because there is a minimum still. And if you're on zones, it has to be like, if you're going to be zoning, you really want to make sure it's done correctly. But it is much better, to your point, with the inverter driven, that you have a lot more flexibility of the short cycling, where it's not going to short cycle anywhere near like the older units are a single stage. But good question. It's not as much of a concern, but it would be more of a concern on the cooling side of things, not the heating.
Got it. Thanks. And separate question on ventilation in a ductless system. What do you recommend for that? And are there any sort of energy recovery ventilation systems that can pair with a multi-split ductless?
Like an ERV, an energy recovery ventilator, is that what you're saying?
Yes.
Well, that's a standalone unit, so you wouldn't be tying it in with the mini splits. And that's going to take the air from outside and exchange it from the inside and outside here, but it's not going to have anything to do with the mini splits, other than, hey, we might have to figure a little bit more capacity, because you are, they're not 100% efficient, the ARVs. They're about 85-ish. Does that answer your question? I'm not sure if it did.
Well, I guess the basic question is, what techniques do you recommend for ventilation with a ductless system, given that it's closed, there's no air exchange?
Well, that depends on your home. If your home's tight, then you're going to need it. If it's not tight, you're going to get ventilation just through the, your walls and windows and such. If you really want to find out, then doing a blower door test is going to tell you whether you need it or not.
Right. And assuming that the test indicates that ventilation is needed, is an ERV what you'd recommend, or?
Yes, correct. Yep.
Very good. Thanks so much.
The only advantage that an ERV has with a ducted system is that you could actually incorporate it in the ductwork, the existing ductwork. That's the only advantage. Other than that, it has no other. It's a total standalone unit. That's exchanging air from inside and outside.
Right. Okay. Thanks very much for that.
Can Rob, can you explain for our listeners how an ERV doesn't waste? You said it's 85% efficient. How it doesn't waste all the heat, so it exchanges the heat going out with it. Can you explain how that happens? Yeah, so it's essentially a box, and it's got ductwork that's pulling air from inside, and it crosses over a heat exchanger, almost like a radiator, and it's pulling air from outside. And when it crosses over, it's recovering the air from the inside of the house and swapping it with the air coming from the outside that goes into the house. That way there it's just recovering the heat, not the air, right? Yeah, correct. Yeah. It's just passing over a heat exchanger, so at least it's recapturing that heat. Gotcha. But it's like I said, it loses about 15%, which isn't bad, considering. Right. No, you saving 85% of the heat of what you're exhausting. So
Yeah.
Yeah.
But
and,
again, you're not, unless your house is tight, you won't be needing an ERV, but if you want to get your house to be zero, you want to heat it with a heat pump or use as less energy as possible, then you want your house tight and then you will need an ERV. So it depends on where your house sits as far as the efficiency goes.
I listened in on a podcast recently where they were talking about this, and the two guys, the host and his guests, were comparing notes on their houses, both of which were older houses that they'd renovated and tried to make as tight as they could. And one of them said he was at, I don't know, 12 to 15 air changes per hour. So that means that every 12, in an hour, the total volume of air in your house gets changed over 12 to 15 times. So you've heated all the air in your house and it goes out through holes and new cold air comes in, and that happens 12 times for all the air in your house in an hour. You can imagine how much you waste. So the Department of Energy says we're often in the realm of 25 to 40%, I think, of our heating bill goes to pay for lost air. So they said, okay, well, they really tightened it up. They worked it down. They were getting down close to 5 air changes per hour. And apparently that's a kind of a gold standard for a renovated house, that to get it to 5 air changes per hour is you're doing good. And that's at the point where they start to say you ought to have energy recovery ventilation, because then you won't get enough natural. So I think the bottom line, unless you've really, really worked hard and pushed, cracked every single hole you could find, and had a pro do it, you're unlikely to get to that 5 air changes per hour. So you're probably going to get enough ventilation just through natural cycling, airflow. Any other questions? Okay, Anne, please.
Yes, there are times when cooler air comes out of the vents when the heat is on. Is this something that's part of the operation of the system, or is it a problem?
No, it goes through a defrost cycle. When it's below freezing outside, it can freeze. So it actually goes through a defrost cycle and switches. Well, let me back up. How a heat pump works is it's got refrigerant in the system. When it's in AC, it goes in one direction. And when it's in heating mode, it goes in the other direction. So that what it's essentially doing is saying, okay, in cooling mode, your indoor unit is the indoor unit, and the outdoor unit's in the outdoor unit. When it's in heating mode, it flips and it says, okay, I'm going to switch and say my indoor unit is now my outside unit, and my outside unit is now my inside unit. Because in cooling mode, if you went to your air conditioner outside, you're going to feel hot air coming off the top, but you get cool air on the inside. So when you're in heating mode, it's the reverse. Your inside unit is producing the heat and your outside unit is producing cold. So what happens is that it goes into defrost mode, so it doesn't freeze and it has to thaw it off. So, but there should be a setting where you can actually have your HVAC guys set the unit. I don't know whether it's dip switches or the thermostat. It depends on what you have for a unit, where it shuts the fan off so you don't get that cold air. But what might happen is that, okay, it went through that cycle and now it's got to switch back to the heating mode, and then it's pushing the heat through the ductwork that might be a little bit cooler now, so you might get a shot of a little cooler air. But if you notice that it's blowing cold, then
Yes.
it's probably not shutting the fan off
Okay.
when it goes into defrost mode.
Okay. Yeah, definitely. It blows cold, and
Yeah,
It's
that's what it's doing. It's
Yep.
thawing out your frozen condenser outside. So yeah, that and they do make some very interesting noises. These weird whooshings and gurglings, and
Yep.
which is all part of a complex system of checks and balances in these units. So they continue operating well.
One other thing while you're on that, Michael, is The outdoor units actually, most of them go in a higher speed when they're at the highest volume of output than when it's in AC. So you might experience that it's actually noisier in heating mode than in AC mode. So it's just something to expect, be aware of, I should say.
Good. Nancy, go ahead.
Yes, thank you. This is great. I have currently central air, just plain electric, and baseboard oil heat. Based on what you said about, combining the load and et cetera, about getting enough cold air and the heat, is there any way to use the existing central AC with the heat pump separately from a newly installed ductwork for the heat? Does that make any
Yes.
sense?
No, you did make sense. Basically what you're saying is, can I use my existing AC ductwork? Because you have a separate hot water heating system and a separate AC ducted system, and you want to be able to put a heat pump on instead of ACs. That's your question, right?
Well, I'd like to change my oil, get rid of, go all heat pump,
Okay, all
Or
right.
cooling and heating.
It's possible, depending on where your ductwork's located, if it's sized enough, and if it's leaking and all those things that we talked about earlier. It's probably worth a visit to find that out. And it could be a combination of ducted and mini split non-ducted systems that would make it so you can get rid of your oil heat. So it is possible. It's worth a visit, is more how we would know.
Yeah. And then if I can piggyback a second question, please, I've moved and I had a heat pump put into a house that, believe it or not, had radiant heat, or a condo, radiant heat from the ceiling. I don't know, they did that in the 70s, I guess, at some point.
Yeah.
And there was no ductwork existing and no central air. So they put in the one unit, and it was, done from the basement at that point, because it was a one floor deal. So both heating and air conditioning were coming up through the ducts in the floor. That was 8 years ago, and I didn't know anything about the system at that point. Is there one, like Mitsubishi was mentioned at some point in this, and I think I had a Carrier. Is there a gold standard for the people who have the best, mechanisms, best units, one manufacturer over another, or top two or anything like that?
There are some that are better than others, but I wouldn't say there's a gold standard. I mean, 8 years ago, there's been a lot of upgrades since 8 years ago.
Yeah.
So, and what'd you say, you had Carrier, right?
Yes.
And which is a good brand. We put in Bryant, which is the same as Carrier, with a different name on it. And they have a really, really good outdoor unit that goes down to a very low outdoor temperature. Carrier may have had that back then, called the Green Speed, I think it was called. I don't know if that's what you have or not. How low will it go for an outdoor
Well, that's
temperature?
the thing. I was told I'm not there anymore, which is why I need to replace where I am. But I had an elderly mother living with me, and I was keeping it warmer than I would. And one of the times when they came to service, they said, "Oh, well, this isn't designed to heat, that high." And I'm like, okay, you can't put the, temperature to say 76, and the heat pump's not going to, I don't know. But anyway, it had the electric backup, but I don't believe it went even to, it went basically to 30, I think, before.
Okay, all right.
Yeah.
That's probably a myth, Mike, that we didn't talk about. You can't put your thermostat up higher. Hey, if it'll do it, you can do it. if you want, if you put it at 76 and it'll heat to 76, there's nothing wrong with that, right? It's just that we don't design systems for 76, but when it's a warmer temperature outside, it's probably going to do 76 because we designed at 70 inside temperature, roughly close to zero, say 2 degrees, right? So if it's not 2 degrees and it's say 30, 35, 40 degrees, you're going to be able to hit 76, no problem. So
Okay.
that's a myth. I'm not sure why he told you that, but it might have been that it's not designed to go below 30. But hey, if you can get 76 out of your thermostat and that's what you want, then knock yourself out, that
Yeah.
works.
Okay, thank you.
Okay, great. Roy, unmute and
Great, thanks again. I didn't see anybody else looking to ask their first question, so I thought I'd ask another one. And the Department of Energy, the US DOE, has a heat pump challenge with a new spec that's more aggressive than the NEEP spec or the Energy Star spec for heat pumps that has lower operating temperature down to -15 or -20, higher percentage of performance at that low extreme temperature, and also higher efficiency in terms of COP. I wonder if there are any units that meet that spec yet that are commercially available through the channels you use, Mr. Basnett. If so, are they things you'd like to install, or would you want to wait and see some more models come out that meet that new DOE spec?
No, I would like to see that, because I'm always into looking at if it's got a decent COP at a lower temperature, that's great. That's what we're looking for,
I'm looking forward to talking with you about that, Roy. I hadn't heard about that, but that's
Okay,
great.
yeah.
Pushing the
I'll put a
limits.
link in the chat to the spec, and you
Gotcha.
can see that.
Yeah, that'd be great.
All right, let me see. I think few questions. Oh my gosh. Okay, that's okay. Sometimes we have cool air. Okay, that's part of the normal. Okay, yeah, I think we've covered the questions in the chat. So I think we're good. So okay, so I think we'll wrap up now. You want to put the next slide, Belinda? Let's go here. Okay, so this is contact information for Rob for lincolngreenenergy.org. If you want to go to any of the other videos we've done about heat pumps or other topics, it's been quite a run now in the last couple of months. And Heat Smart Alliance is a group. I don't know, maybe probably about 30 communities that are all promoting heat pumps, and they have a system of coaches that get trained to help people with exactly the kinds of questions you're looking at. So that they're a good group to tap. And Belinda has a lot of information. She's a member, as am I, and she's got a lot of good information that could be helpful. And let's go to the resources slide. Okay, so I wanted to highlight the first item on here, the NEEP air source heat pump buying guide. It's a really super document, not very long, but packed full of useful information. If you want to buy an air source heat pump, it doesn't cover geothermal, but it covers air source. All the steps to consider, and how you vet an installer, and just a ton of great information. So you can just Google NEEP ASHP for air source heat pump buying guide, and you'll come right up with it. That's great. Mass Clean Energy Group, a lot of good information on their site. And then Abode here, through the Green Energy Consumers Organization, they will evaluate your proposals from heat pump installers for $150. And I think they do a sort of halfway to that. But anyway, go to this link, and if you're talking about plunking down a lot of money for a new heat pump system, it might be worth getting a pro to look at it and say, hey, yes, they've done a great job, or hey, they're missing some critical information. So that might be a useful thing. So, okay, so thank you, Rob, for finding time to be with us today. Really appreciate you making time and helping clarify what can be a pretty complicated landscape of options. But it was great having you on. And so I just wanted to say one final thing, and Rob mentioned this, but I think it's probably the most important point that was made today, and that is, before you think about a heat pump, think about tightening your house. Air sealing, which plugs all those leaks so you can get it down from 15 air changes per hour to 5 or something like that. And windows, if you've got single pane windows, my gosh, those things are just disastrous. And increase insulation in your attic. It's really pretty cheap overall and make a huge difference. So anyway, tighten up your house first and then do heat pumps. Because if you've got a really leaky house, heat pumps can suck some money out of your wallet. If you're heating the great outdoors, that's an expensive hobby. So tighten up your home and then go with heat pumps. So thank you, Belinda, for keeping everything running smoothly today and dealing with the unknowns as they came up. And thank you, all of you, for joining us and helping make Lincoln as green a community as possible. So thanks all. Have a great day. Bye-bye.